Hello, this is Mr. Svil. Please welcome to my YouTube channel. If you have not yet subscribed, please subscribe and don't forget to press the notification bell icon to get all my latest videos. In the previous tutorial, I showed you on how to determine the maximum and minimum pressure intensity at the base of the wall. So in today's tutorial, we shall look on how to determine the base width of a masonry wall. So before we continue, I had to make a correction. So in the introduction part, I told you that this is somehow of P, but it's an actual P. So we'll make that correction. And also in example 1, where we use this formula, we shall use P is equals to the unit weight of soil multiplied by the height squared divided by 2 multiplied by 1 minus sine of the angle of repose all over 1 plus sine of the angle of repose. So let's get started in today's tutorial. So the question says that determine base width of a masonry wall of height 6 meters and 1 meter top width retaining earth up to top. The top of earth is horizontal and the weight of earth and masonry wall are 16 kilonewtons per meter cubed and 23 kilonewtons per meter cubed respectively. The angle of repose of the soil is 30 degrees and the backfill is vertical. So let us have a look at the solution. So we are given the height of the wall, which is 6 meters, and then the height of the earth, that is small h. We are told that it reaches at the top of the retaining wall, so it's 6 meters also. And then the top width we are given as 1 meter. The unit weight of earth, we are given it as 16 kilonewtons per meter cubed. The unit weight of masonry wall, we are given as 23 kilonewtons per meter cubed. The angle of repose is equal to 30 degrees. So first of all, we shall have to let the bottom width be meters. So here, so the width, let me show you a sketch. So this is a sketch. This is the top width, which is 1 meter. The height of the retaining wall, that is 6 meter, and the height of the earth, which is 6 meter also. And then the distance from AE we don't know, so we say that let it be B meters. So we have let the distance AB to be B meters. So first of all, we shall find the horizontal thrust of the earth, the vertical face, which is P. This is a P, is equals to the weight of the soil multiplied by the height squared all over 2 multiplied by 1 over the sine of the repose angle divided by 1 plus sine of the repose angle. So when you calculate this, you'll get your P as 96 kilonewtons. Then we shall calculate the weight of the masonry wall. So our weight W is equals to the weight of unit weight of masonry wall multiplied by A plus B all over 2 plus our height multiplied by 1. So we shall replace our values. We are given the unit weight of the unit weight of masonry wall as 23. We shall multiply by, we are given A is the top, the width of the top, and then our B is the width of the base. So this B is the one that we are looking for. divided by 2 multiplied by 6, which is our height, multiplied by 1. So we are considering a wall of 1 meter. When you will calculate this, you'll get your answer as 69 into 1 plus b kilonewtons. And then now we shall let x be the horizontal distance of center of gravity of wall from A. So you can see it over here. The distance from it is the distance from the center of gravity to A. So this is our x. When we want to find our x will be equal to a squared plus ab plus b squared all over 3 into ab. Replacing the values, we'll get as 1 squared plus 1 multiplied by b plus b squared all over 3 into 1 plus b, which is equals to, so this is, I have just simplified this, so you'll get it as 1 plus b squared all over 3 into 1 plus b. And then we shall let x be the horizontal distance between center of gravity and the point where the resultant thrust R cuts the base. So we can see that it's the distance from the center of gravity to the point where our resultant thrust R cuts the base here at E. So the distance from here to here is x1. So our x1 will be equal to p all over w multiplied by height all over 3. So we got our p as 96 all over our w, which was 69, into 1 plus b multiplied by 6, which is the height, divided by 3. So when you calculate this, you'll get your answer as 2.78 all over 1 plus b. Then the horizontal distance, that is AE, you'll get by adding x and the values of x1. So we got our values of x as 1 plus b squared all over 3 into 1 plus b. Then the value of x1, we add the value of x1, which is 2.78 all over 1 plus b. When you add this one, you'll get your answer as 9.34 plus b squared all over 3 into 1 plus b. So now we shall calculate the eccentricity. So our eccentricity E is equals to AE minus b all over 2. But to ensure that there is no tension at the basis of the wall, the eccentricity will be equal to b all over 6. Therefore, when we replace our eccentricity with our eccentricity will be equal to b all over 6. Therefore, our eccentricity will be equal to 9.34 plus b squared all over 3 into 1 plus b. So this is our AE minus b squared, b all over 2 should be equal to b all over 6. And then when you bring this minus b all over 2 to the other side, so it will become b all over 6 plus b all over 2. And then adding b plus 6 all over plus b all over 2, you'll get your b as you'll get b plus 3b all over 6. So this is 4b all over 6. So our 9.34 plus b squared all over 3 into 1 plus b is equals to 4b all over 6. And then cross multiplying this, you'll multiply 6 by these values over here, and then this by this 4b. So 6, you'll get 6 into 9.34 plus b squared, brackets, close the brackets, should be equal to 4b into 3 plus 3b. So when you open the brackets over here, you will get 3 plus 3b. So that is what you'll put it over here. And then when you multiply 6 by 9.34, you'll get as 56.04. When you multiply 6 by b, you'll get as 6b. And then multiplying 6 by b squared, you'll get as 6b squared. So this will equal to, when you open the brackets all over here, you'll get as 12b plus 12b squared. And then when I bring all these values to the other side, it will be 6b squared minus 12b squared plus 6b minus 12b plus 56.04 is equals to 0. So I have formed a quadratic equation, and then when I simplify this, I'll get as negative 6b squared minus 6b plus 56.04 minus 0. So this one, I want to find the value of b. So I'll use the quadratic formula, that is minus b plus or minus the square root of b squared minus 4ac all over 2a. So replacing the values, I'll get my b will be equal to 6. This is our b, this one, negative 6 multiplied by negative, so it will be a positive. So it's 6 plus or minus the root of negative 6 squared minus 4 multiplied by negative 6 multiplied by 56.04, close the brackets, all over 2 multiplied by negative 6. And then when I calculate in the brackets, I'll get my value as 6 plus or minus the square root of 36. So this is the negative 6 squared plus 1344.96 all over negative 12. And then adding this one, I'll get my b is equals to 6 plus or minus the root of 1380.96 all over 12. And then when I find the square root of 1380.96, I'll get my answer as 37.16. So our b will be equal to 6 plus or minus 37.16 divided by negative 12. And then b, on adding b plus 37.16 divided by 12, my answer is negative 3.596. And then when I minus 6 minus 37.16 all over negative 12, I'll get my answer as 2.597. So I've gotten my b as negative 3.596 or 2.597. So neglecting the negative value as it is absurd, so our b will be equal to 2.597 meters. So in this we don't use the negative value, so we take the positive value. For our case, we have taken as 2.597 meters. Thank you for watching my video. If you have not yet subscribed to my channel, please subscribe, and don't forget to share this video with your friends